Welcome to the Centripetal Force Lab. In this experiment, we'll be investigating the relationship between force, mass, velocity, and radius for an object in centripetal motion and quantifying it by holding two variables constant at a time.
Weigh each of your masses to establish an accurate value and uncertainty for them. Begin by attaching the 5-gram mass to the rotating assembly as shown. Ensure that when stretched, the center of mass reaches the 50 millimeter mark. If the length does not reach 50 millimeters, you may need to adjust the height of the apparatus. Ensure that the string is taut when measuring this length. Open the Data Studio file and select Monitor Data from the Experiment menu. Press Tare on the force sensor to ensure that it is properly zeroed. Turn on the power supply. The exact voltage used and the corresponding velocity are not critical, but the velocity must be constant throughout the experiment. Once the velocity is stable, press Stop and then Start to switch from monitoring to collecting data. Note that the apparatus must be in motion when you press Start because the force data displays an average. Let data collection run for about 5 seconds and record the velocity and force data in your notes. At that point, press Stop, turn down the power supply voltage, and turn it off. Add an additional 5 grams of mass to the apparatus, weighing it as before. You'll need to collect data for at least 6 different masses. Ensure that you adjust the power supply voltage such that the velocity remains the same for each mass.
In Experiment 2, we'll be changing the velocity and measuring the effect it has on the force while keeping the mass and radius constant.
For this section of the experiment, we will use a 30-gram mass. Ensure that the radius is at the same 50 millimeters. Open the second Data Studio file, Centripetal Force B, on the desktop and click Start. As before, press Tare on the force sensor to ensure that it's properly zeroed and begin increasing the voltage on the power supply from 0 to 10 volts. During this process, hold the stand as best you can to help minimize vibrations. Data Studio will record the force and velocity data, which you will need to export to a file for later analysis. You can accomplish this by clicking File, then Export Data.
In Experiment 3, we'll be varying the radius and observing the effect on the force while keeping the mass and velocity constant.
Open the Data Studio file, Centripetal Force C, on the desktop. For this part of the experiment, you will need to adjust the spoke arc length each time that you change the radius. To do so, press Setup in Data Studio. The spoke arc length is equal to 2 pi times the radius and can be calculated as we've shown on screen. Enter this value into the appropriate box. Next, close the Setup window and select Monitor Data from the Experiment menu. At this point, you'll need to turn on the power supply and increase the voltage until the velocity attains a specific value, say 2 meters per second. Record this value. Without changing the voltage, turn off the power supply and press the Tare button on the force sensor. Turn the power supply back on, and in Data Studio, press Stop then Start to switch from monitoring to collecting data. Allow data collection to run for 5 seconds and then press Stop. Record the force and radius values in your notes. Adjust the height of the apparatus to change the radius, and repeat the measurement for at least 6 different radii.
Thanks for watching the Centripetal Force experiment, and we hope your lab report runs circles around the competition.